All right, let's talk about the quadratic formula. Now this, for our class, college algebra, this would be considered a review topic, but truth is, I think a lot of people in our class need to review. And best part about, or one good thing about doing the class by video is if you don't need to review this, then this is not a video you need to watch, all right? But, all right, the quadratic formula. First, what is it? We use the quadratic formula to solve problems that look like that. Okay, so this one says x squared plus 5x plus 6 is 0. Tell me what the x needs to be to make this statement true. Okay, now the formula that's going to give us the answers to this is called the quadratic formula, and it looks like this. You solve the equation ax squared plus bx plus c equals 0 by these formulas. Okay, now a is a number given in the problem, a times x squared. B is another number given in the problem, and c is another number given in the problem. So you can see, like, I have a number times x squared plus another number times x plus another number equals 0. So the solutions look like this. You take the opposite of the number b plus root b squared minus 4ac over 2a. So you do all that stuff, right? And you reduce it to an answer. What's the difference between these? This says the opposite of b plus, and this is the opposite of b minus, all right? And I just want to mention it that way so that you can see there are two things. And the only difference between these is the plus and the minus. Okay? Now, most people who show you this aren't going to write it like this. They'll write it this way. Okay? They'll say the opposite of b plus or minus root b squared minus 4ac over 2a. But that plus or minus, that's two different things. Okay? There's a plus, and you do all the math with the plus, and then there's the minus, and you do all the math with the minus, and that's two things. Okay? All right. Also, to avoid mistakes with the signs, you know, in algebra, it's so easy to make a mistake with the sign, the plus and the minus. Read that negative b, read it as the opposite of b. What's going to be right here is the opposite of whatever that number is right there. Okay? All right. So, one more thing. Okay, so vocabulary. Okay, you got to know the vocabulary. It's not usually what I emphasize when I teach, but we should know what things are called. Do you see this right here? That's called a quadratic equation. Ax squared plus bx plus c equals 0. And what we want to do is find what x needs to be for this equation to work. That would be what finding the answers are. This is called the quadratic formula, and it's what we use to solve quadratic equations. Okay? So that's some vocabulary. Let's do some math. Okay? Can you get this formula to work over here? So let's do like this. Can we agree, just for the sake of comparison, that the numbers that we're going to use are that a is equal to 1. I'd have to see this like 1 times x squared. A times x squared. And then I'd have to see that b was 5, right? Plus b times x plus 5x. And then c was equal to 6. So those are the numbers that are going to go in there when I do the opposite of b plus or minus b, you know, all that. So here, let's do like this. I'll do the opposite of b plus or minus root b squared. Okay, so 5 squared minus 4 times a times c. Can we agree about that? The opposite of b plus or minus root b squared minus 4 times a times c. So once we identify what all the numbers are, we just plug them in and we see what we get. Okay? All right. Oh, what's the last part? Over 2a. So 2 times 1. So there's the whole formula. I went ahead and I wrote the plus and minus together to save a little space. So this is going to tell me what the x in that equation needs to be for it to work. Okay? Now, hopefully we're going to get a simpler answer than that. That looks kind of complicated. Let's try to work that out and see if we can get something that's really simple. So let's see. I got -5 plus or minus. What about this? What's 5 squared? Well, that's 25, right? Minus, what's 4 times 1 times 6? Well, that's 24. Okay, so I got it nice and neat there. What's 2 times 1? 2. All right, getting a little bit closer. What number do I get right there? I gotta work this out. Can't really do anything with the 5 or the 2 or the plus or the minus until I tell you what this is. 25 minus 24, that's 1. All right, so here we go. -5 plus or minus root 1 over 2. Okay, can we take it any further? Well, what's root 1? What's the square root of 1? The square root of 1 happens to be 1. All right, so we're almost there. We're getting pretty close. So I get like so. Okay, now here there are two things, the plus and the minus. We'll do them separately. So let's do like this. First of all, what is -5 plus 1 over 2? Well, -5 plus 1 is -4. And -4 over 2 is -2. So there's one of our answers. Okay? And now the minus, -5 minus 1, that's -6. -6 divided by 2 is -3. All right, we have our answers. The answers to that equation, the solutions, turns out there's two solutions. -2 will work and -3 will work. Okay? All right. So what you've seen here, you got the big picture. This is the kind of problem we solve. That's the formula that gives us our answers. And I do the math from there. Okay? Now that might be all you need to see, but I like to encourage people to learn as much as they can. You know, I just believe in learning things, and if you're in school, maybe you believe in learning things too. I don't know. So here's what I want you to think about next. Does it really work? Are the solutions to that equation I was just working on really -3 and -2? And how can we know for sure? So that's all a little bit philosophical, but I think that's part of learning is understanding. Okay? I think people can go through the motions, plug numbers in formulas, and type the answer in. You know, but do you know what's happening? Okay, does it really work? Are the solutions really -3 and -2? And how would we know for sure? Well, we can always check our answer. If I say I found an answer to this equation, that means if I put that number in, it will give me a true statement, right? So say I take x as -3. I have my equation there. I put -3 into it. -3 squared plus 5 times -3 plus 6 equals 0. And if that's a true statement, if that's really equal to 0, then that really is an answer. Same thing with -2. So let's try it out. This is how we know for sure. So 9, -3 squared is +9. -3 squared is -3 times -3. Okay, so it's 9 minus 15 plus 6 equals 0. Is it? Is 9 minus 15 plus 6 equals 0? Let's see, 9 minus 15, that's -6. Is -6 plus 6 equal to 0? It is. That number made this statement true. That's what makes that number a solution. What about the other one? I take -2 and I plug it into the same equation. Does it work? So -2 squared is 4. 5 times -2, -10 plus 6 equals 0. Is that true? Is -4 plus 10 plus 6 equal to 0 or not? So we'll see. 4 minus 10, That's negative 6 plus 6. That is, in fact, equal to 0. So these are two different numbers, but they both made that one equation work when we put them in. So that's how we know for sure. That's what an answer is. Okay, so just don't take this for granted. If I'm ever solving an equation and I claim that I know the answer, all that means if I put that number in, it's going to work, right? Okay, so there, we got kind of the basics down. Let's look at this a little further. Before I do my next problem, I think it'd be good to review some other things, okay? There's always lots of reviewing. There's lots to know in math. But let's think about like this. I want to compare two problems. Do you know how to reduce this? And do you know how to reduce this? Well, this one's easy. Root 16 is 4. Because 4 squared is 16. Okay, so that one's easy. What about root 32? Is there a number you square to get 32? Like if I say 4 squared is 16, is there like a nice whole number you square to get 32? There isn't a number like that, okay? So we say this is not a perfect square right here. 32 is not a perfect square. But here's what we can do. Can you factor 32 with a number that is a perfect square? And let me tell you why I would aim to do that. Now, I've already mentioned that there's lots to review in math and there's lots of rules and so on. Here's a rule that would be applicable in what I'm about to do. Square roots can be applied individually over multiplication. So say I have the root of number A times number B. Then you could work that individually as the root of number A times the root of number B. If you wanted to do that, you can. If that's multiplication, A times B. So I'll have a way to do this if I can think of a way to factor 32 that involves a perfect square. Well, 32 is 16 times 2. Okay? All right. Is that true? Is 16 times 2 32? It is. All right, it's a true statement. Why 16, though? Of all the numbers, why did I choose 16? I could have said 32 was 4 times 8. Well, I chose 16 because of what I can do here. This would be the square root of 16 times the square root of 2. What's the square root of 16? It's 4. So it gives us a way to reduce this. All right? It's not a perfect square. I can't say root 32 is a nice round whole number, but by factoring, I can reduce it a little bit. So this is something that we need to know how to do. Now I know I mentioned it, but it's also true that 32 is 4 times 8. And I could have done it that way, but then I would have to repeat it again on the 8. All right? Like I'd have to say root 4 is 2, and then root 8. Okay, but then what's 8? 8 is 4 times 2. So what's root 4? It's 2. So you'll still get there, but what you want to do is take your number, think of the biggest perfect square that will factor out of that number. Okay, so that's something that we'll need to know how to do. Another thing is like how we reduce by canceling fractions like this. And here's what I'm afraid of if I show you something like this. You're going to want to cross out the 2's there. All right? It's very tempting, and it looks correct, but it isn't. Now, here's what we can do, though. You cannot cancel the 2's. All right? I'll explain why in a minute. If you wanted to reduce this, you have to look at it like this. This would be a right way to reduce it. Why is this valid? Well, an equation should go both ways. So, can you take these two things and combine them into that? You can, because you can subtract fractions with a common denominator. And if you were to subtract these, given that they have a common denominator, be 2x minus 9 all over 2. That's what this is. So if you can go one way, you can go the other way. Another way to look at this is you don't cancel the 2's. The way that this bar here, this division is understood, is both of these terms get divided by that. All right? Now you can cancel the 2, right? 2 over 2 right there. That's going to be x minus 9 over 2. So you can reduce like that. You could even say x minus 4.5, since 9 over 2 is 4.5. Just don't cancel the 2's. It doesn't work. Okay, it just doesn't work. Now, all right, so that's kind of a minor detail, but it's something that we're going to run into, and I don't want you to cancel the 2's there. So many people would do that. It looks right, but it's just one of those things that's tempting and looks correct, but ultimately is wrong. So we'll proceed in a manner something like this. Okay. All right, so let's try another problem now that is a quadratic equation. And it will involve some of the things I just reviewed with you. Now remember, quadratic equation solved by quadratic formula. All right? So let's figure out what's A and B and C in our quadratic equation. Well, so A is 7, ax squared plus bx. What did that equation look like? Remember, ax squared plus bx plus c. Okay, so it says plus bx, but that's obviously a subtraction. So b is going to be minus 2. And then plus c, so c is minus 1. So I know when you look at this formula I gave you, and it says ax squared plus bx plus c, you know, there's pluses everywhere. Well, that, you know, if there's pluses, the numbers are positives. If there's subtractions or minuses, the numbers are negative. All right? Okay, so I got A, I got B, I got C. So what's our answer? Here's what the quadratic formula says. It says the opposite of B plus or minus B squared. So b's negative 2, I'm going to square negative 2. You see that parentheses indicates it's not the 2 I'm squaring, it's the number negative 2. That's what's in there. So b squared minus 4ac. Okay. So sorry, I want to make this nice and neat. So that's every number where it's supposed to be the right way. Down here, 2a. Alright, now once again, I want to try to get this down to some simple answer, as simple as I can get it. So let's reduce this in whatever ways that we can. Okay, so what's the opposite of negative 2? Well, that would be 2. And now let's work out this part in here. Negative 2 squared, what's negative 2 squared? Well, that would be negative 2 times negative 2, so that's 4. And then, what is negative 4 times 7 times negative 1? That's going to be plus 28. Alright. And down here, 2 times 7, that's 14. So I'm getting a little bit closer. 2 plus or minus root 32. Now maybe now you can see why I reviewed something just a minute ago. What's root of 32? Is root of 32 a nice whole number, a nice round number? It isn't. It's not like root 16. Root 32 would need to be reduced like this. Okay? Alright, so let's see. I've already done it right here, so I'm just going to use my result. I just want to bring this up before we got into it right over here. But yes, root 32, we can reduce a little bit like that for root 2. So let's do this. Let's say 2 plus or minus 4 root 2, that's root 32, over 14. Now, what about the canceling? What can you cancel here? 2 and 14? 4 and 4. How exactly do you do that? Well, that's kind of like this. Each of these numbers gets divided by that, right? That's how we look at it. Okay, so I could do like this. 2 over 14 plus or minus 4 root 2 over 14. And then these I individually reduce. So 2 over 14 reduces to 1 over 7. What about 4 over 14? Let's see, 4 over 14. 4 is 2 times 2. 14 is 2 times 7, right? 2 over 7. Okay, so 2 root 2 over 7. The 4 and the 14 cancel as a 2 over a 7. I'm just going to leave this behind. Now, you could give your answer this way if you want to. That's a complicated answer. It doesn't get any simpler than that, though. That's as simple as that answer is going to be. It's not quite like the first problem we did, where I said the answers to that equation are -2 and -3. Nice round numbers. This is the best we're going to do on this one. Okay? So you can give your answer like that. You could also, if you wanted to, combine these back together. Can you add and subtract these fractions back together if you want to? Well, sure. You can add or subtract fractions with a common denominator here at 7. So it would be 1 plus or minus 2 root 2 over 7. Okay. Or it doesn't matter. You're like, no big deal. Either way. Okay? All right. Now, unfortunately, the way that this works is there's lots of ways I can show you to do any problem. And somebody else might show you something slightly different than me. And I try not to get into the territory of showing you lots and lots and lots of different ways to do things. But I'll make a few comments just to try and cover all the bases. Remember right here, and I said you can't cancel the 2. You've got to reduce like this. What I'm saying is you can't cancel things attached with an addition or subtraction. Like, why can you cancel the 2 here, though, but not here? Well, because if I take x and I multiply it by 2 and I divide by 2, I'm just going in circles. I'll leave myself with just x. But here, that's not 2 times x up there. It's 2 times x, take away 9. Dividing is not the opposite of subtracting. Dividing is the opposite of multiplication. That's why I got to look at these individually. Okay? All right. Now, so with that being said, another way that you could have taken it from here, given that I can only cancel things with division that are multiplied, is I could have seen that there's a common factor of 2 up there. All right? So 2, 1 plus or minus 2 root 2 over 14. Okay? So I could have seen it like that. But again, with caution, I'm telling you this. I'm not trying to tell you too many different things, all right? And then that says 2 times. I got 2 times this number over 14. And the 2 and the 14 cancel as a 1 over 7. So I'll get 1 plus or minus 2 root 2 over 7. I'll get the same thing. So you could do like that. Now, it doesn't matter. I'll show you the different ways you can handle the problems. Maybe one way appeals to you or seems easier to remember. That's what you go with, all right? Okay, so let's do one more. See this one right here. Okay, one more example. So can you solve this by the quadratic formula? Let's see, I'm going to go back and look at something. You solve equations like this, ax squared plus bx plus c equals 0, by the quadratic formula, which looks like that. Okay? That's how it works. But does this look like ax squared plus bx plus c? I see 3 terms there, right? And this has 2 terms. Well, let's do like this. I think I can make it work. Ax squared plus bx plus c. It's like that b is 0, or it's like it's not there. So how about we say x squared plus 0 times x minus 9 equals 0. We can see it like that. And then it is a quadratic equation. Okay? Then it is ax squared plus bx plus c. And am I right? Is 0 times x 0? And does it take me, can I go from here back up to there? Sure, so I can go this way too. So this is a quadratic formula with these numbers. Am I right? 1x squared plus nothing times x minus 9. A is 1, b is 0, c is negative 9. All right, so yes, quadratic equation. I'll use the quadratic formula with those numbers right there. Now, I'll go ahead and do that, and I'll give you my answers. But I'll maybe try to get you to notice something. You might avoid sometimes just jumping right into the solution. Is that simple enough you can solve by looking at it? What do you square take away 9 to be 0? Isn't 9 minus 9 0? What do you square to get 9? 3 squared. 3 squared is 9 minus 9 is 0. If x was 3, this would work. And if x was negative 3, it would also work. This one will have pretty simple answers. But if you don't notice that, we got this. Okay, so here it goes. Quadratic formula tells me my answers to that problem right there are going to be negative b plus or minus b squared minus 4ac over 2a, right? That's what the quadratic formula says, and that's what's going to give me my answers to this. I know the answer is going to be 3 and negative 3, though, but let's verify it that we can do it this way. Okay, negative b plus or minus b squared minus 4ac root 2a. Let's see what we can do with this. What's the opposite of 0? 0, okay. So I got 0 plus or minus root. And what about this part in here? What's 0 squared? 0. What's negative 4 times 1 times negative 9? That'll be positive 36. And then this will be what? 2. 2 times 1 is 2. Now we're getting pretty close. Let's see. 0 plus or minus. What's 0 plus 36? That's just 36. Okay? And then what's root 36? Is that a perfect square? It is. The square root of 36 is 6. Okay? All right, now here's my answers. I get 2 answers. 0 plus 6 over 2, 0 minus 6 over 2. So one at a time. What's 0 plus 6? 6. What's 6 over 2? 3. 3 is an answer. Well, I spoiled that from the beginning. I told you a 3 would be an answer, but, well, we got it this way too. What's 0 minus 6? That's negative 6. What's negative 6 over 2? Negative 3. Well, again, I spoiled that one. I said negative 3 would work. Negative 3 squared is 9, and 9 minus 9 is 0. So those are real easy to check up there and see that they work. But I wanted to show you this last example because I thought that it might not have looked like the first one, and that you might not have realized that you could work it the same way. But it's all about seeing that there's a 0 in there. Sometimes we got to notice things like that to get things to work the way that we need them to work.